You've probably seen these images floating around online, these neat, almost futuristic-looking stacks of Mac Minis. We're talking dozens of them, all wired together, creating what looks like some kind of homemade data center. And when you first see it, well, it's just plain weird. I mean, this is the Mac Mini we're talking about, right? The humble little computer designed for a quiet office desk, not for, powering the AI revolution. And yet, here we are. People are buying them in bulk, stacking them to the ceiling, all in the name of building powerful artificial intelligence. So that brings us to the big mystery we're going to solve together today. Why in the world are people choosing these small, quiet, unassuming machines instead of the giant, roaring, power-hungry graphics cards that everyone says you need for AI? The answer, it turns out, is this really fascinating story about cost, power, and a truly brilliant piece of engineering that's hidden inside every modern Mac. And let me tell you, it completely changes the game. So to get to the bottom of this, we're going to follow a really clear path. First, we're going to dig into why running AI is so incredibly demanding in the first place. Then we'll pull back the curtain and reveal the secret weapon hidden inside these Macs. After that, we'll put the Mac Mini head-to-head with the old-school solution. And finally, we'll talk about what all of this means for the future of AI in all of our homes. Okay, so to really appreciate why the Mac Mini is the hero of this story, we first have to understand the villain. We have to understand the main obstacle, the huge wall that pretty much everyone hits. See, running those really powerful, high-quality AI models on your own computer, offline, not in the cloud, well, it comes with a massive and very, very specific requirement. And it's not about having a super fast processor. Modern AI is hungry for something else entirely. And that special something is called VRAM. Now, in the simplest terms I can put it, the more VRAM you have, the larger, the smarter, the more complex the AI model you can work with. Let me rephrase that. Think of VRAM as the AI short-term thinking space. It's like your own brain. If I ask you to solve 2 + 2, you barely need any mental space for that, right? But if I asked you to map out a complex engineering project or write a novel, you'd need a ton of mental space just to hold all the ideas, the characters, and the plot points in your head at once. It is exactly the same for an AI. A tiny bit of VRAM lets it handle simple stuff, but a massive amount lets it tackle truly mind-bending problems. So let's get a little more specific. What exactly is VRAM? Well, the term stands for Video Random Access Memory. For decades, its main job was to make your video games look amazing. It's a special kind of super fast memory that's built directly onto a graphics card, a GPU, to help it draw all those complex images on your screen in a split second. But it turns out, the very thing that makes it great for gaming also makes it perfect for the kind of math that AI needs to do. The best analogy, really, is to think of VRAM as the AI's personal workbench. Imagine an AI is a master watchmaker. A tiny little workbench only lets you assemble a simple digital clock. But if you want to build a grand, intricate grandfather clock with thousands of moving parts, you need a gigantic workbench to lay out all the blueprints, every single gear, and all of your tools at the same time. For an AI, those gears and blueprints are the billions of parameters that make up its brain. To think properly, it needs to have all of them laid out on that workbench, ready to go. So if the name of the game is just get as much VRAM as possible, the solution seems pretty obvious, right? Just go out and buy the biggest, baddest graphics card you can find. Probably something from NVIDIA, since they basically own the market. And for a long, long time, that was the only answer. But here's the catch. For the average person, for you or me, who just wants to mess around with high-end AI at home, this path is basically a dead end. It's blocked by some absolutely massive obstacles. Obstacle number 1, the sheer amount of VRAM you need. We're not talking about the 8 or even 12 gigabytes you might find in a pretty good gaming PC. No. To run the really interesting stuff, the big language models that can write poetry or the image generators that create art that looks real, you need to start thinking about 24 gigabytes of VRAM as your starting point, as the bare minimum. And honestly, the more the better. That number, 24 gigabytes, is a huge dividing line. It's the line that separates the hobbyist gear from the professional grade stuff that truly unlocks an AI's potential. And that leads us right into the second and maybe the most painful obstacle of them all, the cost. To get that 24 gigabytes of VRAM, you have to buy a top-of-the-line, absolute beast of a graphics card. And we are talking about cards that can cost around $4,000. Let that sink in for a second. $4,000 US for a single part of your computer. That is just insane. That's more than most people's entire computer setup. And that's if you're lucky enough to even find one for that price. This isn't just a high price tag. It's a giant keep-out sign that locks students, artists, and small businesses out of the game. But okay, let's just pretend for a second. Let's say you've got the cash. You're still not in the clear,
because then you run smack into obstacle number 3, power. A single one of these high-end cards, when it's really working hard, can suck down around 500 watts of electricity. To put that into perspective, that's like running a big screen TV, a game console, and a mini fridge, all at the same time. And this has 2 huge consequences. First, your electricity bill is going to skyrocket. And second, all that power turns into heat, a lot of heat. Your office will literally turn into a sauna, and you'll need extra fans just to keep the whole thing from melting. It's loud, it's hot, and it costs a fortune just to keep it running.
So what's the takeaway here? The main point is this. For most people, the traditional path to powerful personal AI is pretty much blocked. The price is just way too high, the power it uses is genuinely terrifying, and the heat it kicks out is a huge practical problem. This massive roadblock is what forced people to get creative, to look for a smarter way. And they found one in the most unexpected place. And this, my friends, is where our little hero, the Mac Mini, finally steps onto the stage. The reason this tiny office computer has become the secret key to unlocking personal AI, well, it all comes down to a really fundamental design choice Apple made with its M-series chips. It's a concept that doesn't just bend the rules we just talked about, it completely shatters them. And it's called unified memory. So what on earth is unified memory architecture? Well, on a technical level, what it means is that the computer's main brain, the CPU, and its graphics brain, the GPU, don't have their own separate little piles of memory anymore. Instead, they both have access to one single, giant swimming pool of memory that they share. Let me rephrase that. Most computers are like a company where every employee has their own private notepad. But in an Apple Silicon Mac, it's like everyone is in the same conference room working together on one giant whiteboard. There's no separation. It's one big shared resource for the entire team. And this comparison just illustrates the difference perfectly. Over on the left, you've got your traditional PC. Imagine 2 workers, the CPU and the GPU, and they each have their own personal toolbox. Now, if the GPU needs a wrench that's in the CPU's toolbox, the CPU has to stop work, find the wrench, walk it over, and hand it off. This constant copying of data back and forth creates a huge traffic jam. It's slow and it's inefficient. Now look to the right. That's Apple's unified memory. This is like a big, beautiful shared workshop where every single tool is hanging on a central wall. Both the CPU and the GPU can instantly grab any tool they need whenever they need it without asking permission or waiting around. It is just unbelievably efficient. And this incredible efficiency is what leads to the magic, the aha moment for AI. Because there's only one pool of memory. The computer's main RAM is the VRAM. Let me say that again because this is the absolute key to this whole thing. The RAM and the VRAM are one and the same. This breakthrough changes everything. It means you no longer have to go out and spend thousands of dollars on a graphics card just to get VRAM. The VRAM you need is the same RAM the computer uses for everything else. So, just like it says here, if you buy a Mac Mini and you configure it with 16 gigabytes of RAM, you effectively have a graphics processor with 16 gigabytes of VRAM. If you upgrade it to 32 gigabytes of RAM, boom, congratulations. You now have a massive 32 gigabytes of VRAM for your AI to play with. So now we can finally connect this amazing piece of technology back to those real-world problems we talked about at the beginning. Remember, the traditional path was blocked by insane costs, crazy power usage, and this fixed amount of expensive VRAM. So now let's see exactly how the Mac Mini, with its unified memory secret weapon, just completely solves every single one of those problems. This slide just lays it all out crystal clear. Let's walk through this, head to head. First up, cost. On the right, you've got that $4,000 NVIDIA card. On the left, the Mac Mini, a whole computer, mind you, costs just a tiny fraction of that price. It's not even a competition. Next, power usage. That high-end GPU is an energy vampire, guzzling around 500 watts. The Mac Mini, even going full throttle, maxes out at around 150 watts. That's less than a third of the power, which means less heat, less noise, and a much happier electricity bill. And finally, the most important metric of all, effective VRAM. With the big GPU, you are stuck with its 24 gigabytes. That's it. But with the Mac Mini, your VRAM is simply how much RAM you decide to buy. You can easily get a machine with 32 gigabytes, which gives you more AI workspace than the card that costs thousands of dollars more. It's cheaper, it's more efficient, and it gives you more of the one thing you need most. It's a total knockout. Okay, so that completely solves the mystery of why one Mac Mini is such an amazing tool for AI. But it doesn't quite answer that very first question, does it? Why are people stacking them like pancakes? The answer is all about teamwork. It's about getting these individual machines to work together as one giant superbrain. This is called scalability, and they do it by building what's known as a cluster. Let me break it down with an analogy. Think about building with Legos. You start with one Mac Mini. That's your first powerful AI node, your first building block. It can run a huge AI model all by itself, no problem. Then when you need more power, what do? You just add another Lego brick. You connect a second Mac Mini, and you can have it run a totally different AI model at the same time, or you can have them team up on a bigger project. And by stacking and connecting many of these machines, you are literally multiplying your power. If you have 10 Mac Minis, each with 32 gigabytes of RAM, you've just built a system with a combined 320 gigabytes of memory. The final result is this incredibly powerful, flexible AI system that costs just a fraction of what a traditional server with that kind of power would. So, we've solved the technical puzzle. We know how and why it works. But the implications here, they go so much deeper than just a clever hardware trick. What we're really witnessing is a fundamental shift in who gets to play in the AI sandbox. This is all about the future of do-it-yourself AI. And that really is the bigger story here. This isn't just some fun project for tech nerds. It's about the democratization of powerful artificial intelligence. For so long, the ability to work with cutting-edge AI was locked away inside giant corporations with billion-dollar data centers. This whole Mac Mini movement puts a huge slice of that power into the hands of people like you and me, individual researchers, artists, small businesses. A university student working from their dorm room can now run experiments that were once only possible at a place like Google. It truly levels the playing field. So, before we wrap up, let's just take a deep breath and walk through the key pieces of this puzzle one last time, nice and slow. First, we had the problem. To run powerful AI, you need a massive amount of special memory called VRAM. Then came the obstacle. The normal way to get VRAM, using those big graphics cards, is wildly expensive and uses a terrifying amount of electricity. Then we discovered the secret, Apple's game-changing unified memory, a clever design where the computer's regular RAM is also its VRAM. And that led us to the solution. This allows a small, affordable, and efficient computer like the Mac Mini to provide a huge amount of VRAM, making it the perfect building block for a powerful, personal AI system. When you really step back, this whole story isn't just about computers and memory. It points to a much bigger, more exciting shift, and it leaves us with one final question to think about. The question is no longer if regular people will get access to this kind of power, but what will they do with it? What incredible new art, what game-changing scientific discoveries, and what revolutionary ideas are going to bubble up when the power to build with advanced AI is no longer trapped in giant data centers, but is sitting right there on the desks, in the homes, and in the hands of everyone.
If you enjoy this video, please like, share, subscribe, and hit the bell to the later update from my channel. Thank you for watching till the end, and see you in the next video.